Hello and good morning dear students. So in today's class we'll start with question number 22. Okay, so in question number 22 the question says the probability that a student will get A, B, C or D grade are 0.4, 0.35, 0.15 and 0.1. Okay, so these are the grades that a student can get, A, B, C, D respectively. Okay, find the probability that C will get B or C grade. Number one, and number two, at most C grade. Okay, events of getting A, B, C, D grades are mutually exclusive. Okay, now first of all, A, B, C, D are the grades, okay, that the students will get, and A, B, C, D are mutually exclusive events. So the intersection of A into B, B, C, C, D, these are all zero. Okay, the first question is to find the probability that a student will get either B or C grade, that is B union C. Okay, so B union C, I've written the formula out here. B union C is probability of B plus probability of C minus probability of B intersection C. And since A, B, C, D are mutually exclusive, B intersection C will be 0 directly. Okay, and from here, what is the value for P of B? So 0.35 plus 0.15 minus 0, this will be 0.50, which is 0.5. Okay, so this is your first answer. We move to the next one. Now, probability at most C. Probability at most C means at most C should get. That is C or D, probability of C or probability of D. If you read the hint out here, the hint says at most C grade means C or D. Okay, so this means probability C union D, that is PC plus PD, and we know intersection is 0. So what is PC? Probability of PC 0.15 plus 0.1. which is 0.25. So this is your question number 22. Pause the video and note it down. Alright, let's proceed with question number 23 now. Now as we move ahead, question number 23 and question number 24. Okay, I mentioned yesterday we have to use the formula of NCR. Okay, so let us start with the formula of NCR. What is NCR? Out here C means the combination. Now, if you haven't done chapter permutation and combination, for the time being, you just remember the formula NCR. Why do we use this formula? Whenever we are drawing two balls or two cards, more than one, then we have to use NCR formula, okay, combination. Now, NCR means out of total, how many you are drawing? For example, we are drawing two cards at a time. So out of how many? Out of 52, right? Out of 52, I am drawing two cards at a time. So in this way we can understand NCR. N means the total, NCR means how many times you are taking it, either two or the thrice. Okay? Are you understanding my point? So this is the new formula first. The formula is factorial N. See this symbol. This stands for factorial. Okay, now I am explaining what is factorial. Factorial N divided by R factorial, and within the bracket N minus R factorial. So this is the formula of NCR. Once again, factorial N divided by R factorial into N minus R factorial. Okay. Now, factorial 2 means 2 into 1. Okay, please go backwards. Factorial 3 means 3 into 2 into 1. Factorial 4 means 4 into 3 into 2 into 1. Factorial 5 means 5 into 4 into 3 into 2 into 1. So in that, factorial 6 will be 6, 5, 4, 3, 2, 2, 1. Okay, 7 will be 7, 6, 5, 4, 3, 2, 1 into product. So this is the formula for NCR factorial. Okay, so please note down the formula. Now we'll go to question number 23. Alright, let's go with the question. That is question number 23. Now I have told you whenever we are drawing two cards or two balls at a time, okay, then we have to use the formula of NCR. Please remember that the formula of NCR is factorial N divided by R factorial into N minus R factorial. And how to calculate the factorials I have given out here. Okay, now let's read the question. The question says 2 cards are drawn at random from a pack of 52 playing cards. 2 cards are drawn. Are you understanding my point? From 52 playing cards, I am drawing 2 cards at a time. Okay? So out of 52 playing cards, when I am drawing 2 cards at a time, how many different combinations I can draw it? Are you understanding my point? In how many different ways? So if we calculate that, it will take a long time. But if I use the formula of NCR, in how many different ways I can take it out? Because there are 52 playing cards. I can draw an ace of speed, and I can draw a diamond of 2. That is one way. I can draw ace of speed, and I can draw king of heart. That is the second way. There are so many different ways. Okay, you can even calculate. So the best way to find, now here, 2 cards are drawn from a pack of 52 playing cards. So this is the experiment going on. So what will be my sample space? My sample space will be not the sample space. In how many different ways? Or you can also take it as sample space. Okay, in how many different ways I can take it out? 2 cards from 52 playing cards in how many different ways? In this very different ways. 52 CR. 52 is the total number of cards. And how many cards are drawing? 2. So 52C2. Understand my point? In 52C2, using this formula, factorial 52 divided by 2 factorial into 52 minus 2 factorial. Okay, so 52 minus 2 means 50 factorial, and 52 factorial we can write it as 52 into 51 into 50 factorial divided by 2 into 1 into this is 50 factorial. The reason I've stopped at 50 factorial is because 50 and 50 gets cancel out. So this and this gets cancel out. So 2 ones are 26 times, and if you multiply 26 into 51, then we get 1326 many different ways. So 1326 different ways we can draw 2 cards at a time. So this is going to be my sample space. Pause the video and note it down. Okay, so that was the sample space. 1326 many different ways we can draw 2 cards at a time. Now the question is, find the probability. Okay, the question is 2 cards are drawn from a pack of 52 playing cards. What is the probability that the card drawn are either both ace or either both black cards? I understand my point. We are drawing 2 cards at a time. What is the probability of getting both ace or both black cards? So for this I need the help of event. So I have mentioned let A be the event that both cards are ace and B be the event that the both cards are black. Okay, so A and B. The question is asking us to find what is the probability that both are red or both are ace or both are black. A and B. So A and B, the formula is this. So therefore probability of A. So probability of A means both the cards are ace. So total in 52 playing cards, how many ace cards are there? 4. So hence 4C2 divided by this is out of 52C2. Now please do understand this properly. Probability of A. What is A? A is the event that the both cards are ace. Okay, so how many favorable chances of getting ace? Because there are only 4 aces. I am standing up point. Out of 4, how many I am taking? And 2. I'm taking 2. So 4C2 in different ways divided by 52C2. Okay, which is this. Plus probability of B. What is probability of B? Black cards. How many black cards are there? 26. So therefore there will be 26C2 divided by 52C2 minus probability of A intersection B. Now A intersection B. A intersection B means that the cards has to be ace with black. The cards has to be ace with black. Because since there are 4 aces, 2 of them are black color, 2 of them are red color, it has to be ace plus black. So hence it will be how much? 2C2. I understand the point. Why is 2C2? Because it has to be ace as well as black. Okay, because if I take 4, there will be 2 red also, which is not considered out here. Okay, so 2C2 divided by 52C2. 52C2. Alright, now what we'll do? We'll find the value for this, and this, because 52C2 we have already found it out. This is 52. Okay, 52C2 we know the value 1326. So what we'll do? We'll find the value for this, and this. Okay, so pause the video and note it down. Alright, so when you calculate the values of 4C2, so 4C2 you calculate, it will be 4 factorial divided by 2 factorial into 2 factorial, we'll get the value of 6. 2C2 will directly be 1. 26C2 will be 325. Please check the values. Okay, and after that, what you will do, we'll put the values back out here. So 4C2, the value for 4C2 is 6 divided by 1326 plus 26C2. 26C2 is 325 divided by 1326 and minus this is 1 divided by 1326. Alright, so now what we'll do, we'll take the LCM. Okay. So therefore, when I take the LCM, it is 1326 will be 6 plus 325 minus 1. So therefore, this is 331. So 330 divided by 1326. Okay? 330 divided by 1326, we can cancel it with 2. Okay? 2 ones are 2, then 2 6s are 12, 2 5s are 10, 2 6s are 12, 2 6s are 12, 2 3s are 6. So 165 divided by 663. Is it possible to cancel with 3? Yes, it is possible to cancel with 3. 3 2s are, 3 2s are, 3 1s are, 3 5s are 15, 3 5s are 15. So hence it is 55 by 221, which is our final answer. So please pause the video and note it down. Alright, we move to the last question of this exercise, and this question is also very interesting, and we have to use Ncr formula out here again. Okay, now the question says, in a basket contains, so there's a bag, there is a basket which contains 20 apples and 10 oranges. So you can see the box out there, that's a basket. There are 20 apples and 10 oranges. Okay, out of which 5 apples and 3 oranges are defective. Okay, so from this bag of 30 fruits, 5 apples are defective and 3 oranges are also defective. So can you tell me what is the number of good fruits out here? Out of 30 fruits, 8 fruits are being defective. So what is the number of good fruits? 22. Okay, let's proceed. If a person takes 2 fruits at random, now there's one guy, okay, who's taking 2 fruits at random. Now he might be getting good also, he might be getting defective as well. Okay, the question says find the probability that either both are apples or both are good. Are you clear with the question? So from this basket, what we're doing is I'm drawing 2 fruits at a time. What is the probability that I'll get both apples or both good? Okay, again for this we have to start with the assumption as the events. We need the help of events. Let A be the event that both fruits are apple, and let B be the event that both fruits are good. See, the assumption or the events have to be taken in such a way so that I get the given probability which I am asked to find. Because I am asked to find the probability that both are apples or both are good. So in that way, the first will be the event both the fruits are apple. Second will be the event that both the fruits are good. Alright? Hence identify the value for this. Since we are drawing 2 apples or 2 fruits at a time, so here also we have to use combination. So probability of A. What is probability of A? Probability of A means both the fruits are apple. Now how many chances are there? How many apples are there? 20. So out of 20, this will be 20C2 divided by, but as a whole there are how many fruits? There are 30 fruits. Out of 30, I am taking 2 fruits at a time. I hope you are getting this now. Okay? The moment you get this, it's very easy to find the value of 30C2, 20C2, anyone can do. Okay? Plus, probability of B. Now what is probability of B? What is the event B? Event B that both fruits are good. Both the fruits are good. Now please be clear. 30 fruits are there. Out of this 30, 8 of them are defective. So what is the number of good fruits? 30 minus 8, 22. I understand the point. So both the fruits has to be good. Both the fruit has to come from good fruits. Okay, so what is the total number of good fruits? 22. So that's why this will be 22. This is 30. No, this is 20. This is 30. 22C2 divided by 22 because number of good fruits, 30C2. The denominator is going to be same throughout, minus probability of A intersection B. The probability of A intersection B. It should be apples as well as it should be the good ones. What is the total number of apples? 20. How many defective apples? 5. So what is the total number of good apples? 15. So hence 15C2 divided by 30C2. You might be a little confused. You might be a little confused with this calculation or with these values. But hang on for a while. Think of this properly. Why have I written 20C2? What is my A? Probability of A. A means both the fruits will be apples. So how many apples are there? 20. That's why 20C2. Because see, I am drawing two fruits at a time. I am drawing two fruits at a time. Okay? Probability of A means what is the chances of getting both apples? Because number of apples are 20. So 20C2 divided by 30C2 because that's a sample space. Okay? Probability of B. What is probability of B? B means both the fruits has to be good. I understand my point? Both the fruits has to be good. Either it be an apple or either it be an orange. Since there were 30 number of fruits and 8 of them are defective, total number of good fruits is 30 minus 8, that is 22. So 22. It can be apple, it can be, orange, it doesn't matter. But it has to be the good ones. So that's why 22C2 divided by 30C2. And the last one, probability of A intersection B. A intersection B means, what is A? Both has to be apples and both has to be good. 20 number of apples, defective 5. So what is the total number of good apples? 15. 15C2 divided by 30C2. What we'll do? Now we will calculate this value. Please do calculate yourself. Alright, so you can see in the board now I've calculated all the values. The value of 20C2, 190. The value for 22C2, 231. The value for 15C2, 105. And the value for 30C2, 435. What we'll do? We'll put all the values in the numerator and denominators, right? So what we'll get then is, see, I'm still finding the value for this. These values we have formed it out here. We are putting back the values. Okay? So therefore, 20C2 is 190 divided by 30C2, 435, plus 22C2 is 231 divided by 435, minus 15C2, 105, 105 divided by 435. So take the LCM 435, take the LCM as 435, so this will be 190 plus 231 minus 105. So therefore this will be 1, 9, 10, 11, 12. So 2, 1, and therefore this will be 421 minus 105 divided by 435. Okay, so let us calculate 421 minus 105. So therefore if we subtract it, this will be how much? 6 and then 1 and 316. So therefore this will be 316 divided by 435. 316 divided by 435. Please check the calculation, pause the video and note it down. And yes, this is the final answer, 316 divided by 435. This is your final answer. So once again, let me repeat this question. The important thing out here, these are not the important things, okay? This anyone can do, but to understand this line is very, very, very important. If you are clear with this line, then I am sure that you can do it very, very easily. Because this calculation you can easily do it in your calculators also. Okay, but this is very important line. This line is very, very, very important. So please do understand it properly. Think of this. Why am I using C? Why am I using combination? Because the calculation becomes very, very easy. Otherwise, I cannot calculate in how many different ways. It's not feasible. Understand my point? So this concept of combination is very useful as well as very, very important. Please do understand the formula and how to define the events. Which event to take it as A, which event to take it as B. That is very important. See, all these things will be easy for you if you are regular in touch with this. Otherwise, you might be feeling probability is very, very difficult. I'll not be able to understand. The things which I learned in class 10 in probability was very easy. Class 12 is difficult. I knew it is difficult, yes, because we are not in class 10 no more, okay? And the things will be changed now. So this was the first exercise. The second exercise we'll do is more interesting. It is known as conditional probability, and we'll be learning more about conditional probability in tomorrow's class. Okay, so complete all these 3 sums. Once again, learn the formula of NCR, complete, okay, and then submit it to me by tomorrow. Take care and bye-bye.